Everyone. I am Sahil Khatri, working as a lecturer in Automobile Engineering Department. I am glad to welcome our today's expert, Mr. San Verma. So, let me introduce our expert. He is associated with the automobile industry since more than 7 years, and he is having a versatile
13.
experience in 13. Okay, so more than 13 years, and he is having a versatile experience in automobiles. Uh, as part, he is also an organizing committee member of Mahindra Baha SA India. So, and he is responsible for static event evaluation at Baha SA India. And he is also a lead judge at various SA events and actively takes part in SA internationals. So, apart from that, not wasting much time, I directly handing over this session to San sir. Sir,
Hi, hi everybody. We are here today to study or to learn about automotive safety. So, Sahil, I'm just wanted to know that can we have a question and answer session? Matlab, we can ask student questions or they can direct us.
yes, sir. At the end of this session, any queries from the students, then I will just moderate that queries. So,
Okay, fine, fine, sure. So, hi students, how are you? I hope you are doing well in this pandemic situation and everything is going good at your end. We will be starting with our automotive active and passive safety systems. I just Sahil, we cannot have we do not have any interactive session kind of a thing wherein we can ask.
no, sir, it is a one-way session because it is a Facebook Live.
Okay, fine,
So,
fine, sure.
okay, sir.
Okay, so we are going to study about active and passive safety systems. Now, in current scenario, what we see that we need advanced transportation system plus safety system. Why? Because we want to build ideal vehicles which are safer and more comfortable. As we see over here, the road accidents is one of the leading contributor in deaths across the globe. And with the rise in traffic accidents has become a problem all over the world. And India accounts for 6% of world death with just 1% of world vehicle population. So you can imagine that we have very less of vehicles, but the rate of accidents is very high. Reason being for that is in India we are very careless about the situations like how to. First thing, we are not aware about the road safety rules. If we see that traffic sense in India is one of the worst across the globe, or we can say one of the worst across the globe, there are few countries which are having much worse traffic than us. Overall, in India, getting a license is one of the simplest things to do. You don't need to give test. Now the things are getting structured, but still it is not in the way, not the way as it should be. Anybody who drives takes a license, although he is aware about the traffic rules or not. It's not a part of question over here. Now with this, when we see that 90,000 deaths every year in India occurs due to road accidents. Now, road safety is one thing, rules which the people who drive can understand and relate to it and can be safe on road is one thing. Second is, after all this situation, can we make vehicle more safe in terms of that we can prevent accident at the first place? And if in case the accident happens, can we rescue the occupant or the pedestrian or other people around the vehicle? How do we do that? So for that, there are two kind of safety systems. One is active safety system and one is passive safety system. Now, if we see that stages of accident, how we can do that? So first is safe driving. Safe driving is wherein we follow all the safety protocols when we are driving. We follow each and everything in terms of safety. Second is accident avoidance. Like we should avoid the situations like Overspeeding should be avoided, drunk driving should be avoided. We should be driving in proper lane at proper speed limits. Many things are there by which we can avoid the accident. And then collision prediction. Now collision prediction is one thing, like humanly what we say, that suppose we are driving और हमारे सामने एक गाड़ी आ गई. For instance, one car is there, and if we have seen it, we try to brake it, brake the vehicle. But when we are not able to brake it, what happens? The accident is going to happen. So that is the collision prediction happens from the driver end. But now with the active safety systems, there are many systems in place in which the vehicle detects that the accident is going to happen and it takes the corrective action to avoid the accident. Similarly, so these are three parts of active safety: safe driving, accident avoidance, and collision prediction. Now, if we talk about once the accident has happened, what do we need to do? Occupant protection, pedestrian protection, and occupant rescue. These three things are there in terms which comes after the accident, which is called as passive safety. Now, there are three elements which work in case of an accident or in case of a safety of a vehicle: is human, the one inside the car who is driving or occupants, and one outside the car who is on the road, maybe a pedestrian, maybe other human or other vehicles driving over there. Then environment, maybe road conditions, wind speed, rainy, foggy, all these weather comes in environment mode. You might have heard many news coming in that there are many accidents happening on Delhi Expressway because of the extensive fog, and there are chain of accident, like 20 vehicle crashed in a row. Then vehicle, how safe is the vehicle? So if we combine these three, we are able to understand that is the vehicle safe for road or not, or we are safe on road or not. At the end of the day, the biggest thing which is important is the human safety, what we want over here. Now, if we come to little definitions, is scientific domain that is related to the study of design, construction, regulation of technology to minimize the occurrence and consequences of road traffic accidents. So these three factors combines automobile safety. Active safety systems are help preventing accidents. They control the dynamics of the vehicle. Passive safety systems is help mitigating the consequences of accidents. They protect occupants and pedestrians. We have a look example, like if you can see over here in the graph, is active safety is hazard prevention. So in hazard prevention is hazard detection, hazard avoidance, and then hazard mitigation, so that the crash doesn't happen. uh, for example, I'll give you a thing that we are driving on a road, there is a car ahead of it, and the car suddenly brakes. Now what we do is we try to maneuver or we try to brake. If the distance is safe enough, we can brake the vehicle and we can avoid the collision. So first part is hazard detection. Hazard detection is at the first moment when we see that the car in front of us has brake. So that is the detection. Now avoidance is either we brake the vehicle or we maneuver the vehicle to the other lane. Now, if you are driving in excessively high speed and you brake the vehicle, it will lead to slippage of tires, which in turn will you will lose the directional stability of the vehicle and you will collide in front of you. Now, so there is a system called anti-lock braking system, very well heard. Everybody might have heard about it. Now what does it do is it prevents your tire from locking. So if the tire is not locking, what you will do is you will be able to easily steer the vehicle and avoid the collision. That is called hazard mitigation. Now supposedly you have crashed. Now passive safety comes in picture. What can be ways so that the damage is reduced? Now first of the very important factors of safety in terms of collision is seat belts. So seat belts secure you to the seat so that you do not crash into the steering wheel or you do not crash into the windshield, and the damage is reduced. Second is your vehicle frame. It is made in such a way whenever the collision occurs, it absorbs the impact inside the body so that the minimum impact comes towards the driver or occupants of the vehicle. Third thing is, suppose you are crashing into a pedestrian. Now, uh, the front part of the vehicle, if you might have seen, all the bumpers and all are made of plastic or soft parts. Why? And there are no sharp edges on it, so that the pedestrians are not affected out of it. Now we come to examples of active safety system. So one is anti-lock braking system, which are the most common right now. We are talking about traction control system and stability control system. Now anti-lock braking system, I have already explained you what it is. Traction control system is when you are trying to say you are driving at a speed of 80 90 and you are taking a turn, or say 100 your vehicle tires tend to slip, which in turn leads to loss of control on your vehicle. So what you will do in that case is, you cannot do anything. So there is a gyro sensor inside your vehicle, which will detect that the vehicle is going out of control and one of the wheel is slipping. So what it will do is, it will tell the system that brake needs to be applied and we need to come in control. We will have a look at a video of ABS and traction control system, so you can understand it in a better way. I'll just play that video for you. While the voice is coming for the video,
No, sir. Voice is not there.
voice is not there.
No, sir.
So,
Sir, sir,
yes.
sir, just present your screen again as a tab. Just stop
I am
presenting.
just a minute. Just a minute. Just a minute.
Okay. Okay.
Okay.
Now again you present your screen. Not entire screen, just a tab, sir. Three options are there.
So I am not getting that option in over here.
If
To
you
just
present,
put the tab. Wait.
sir, if you
Wait. 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 Just a minute. Just a minute.
okay. Sir, do one thing. Just send me the link of that particular video in chat box, so I can share the tab.
It will be done now.
Okay. Okay.
Just it's almost done. It will take a second.
Okay.
Safe braking
Done?
with ABS from
Yes, sir.
Bosch.
Done. Okay.
The need to be mobile is rising.
Traffic is growing ever heavier. Critical traffic scenarios are increasing.
With unclear traffic situations, suddenly occurring traffic jams,
or obstacles.
sometimes only full braking can save the situation. when applying full brakes in critical situations, or when braking on slippery roadways, the wheels can lock. The vehicle can no longer react to the driver's steering, because the locked wheels can no longer convey the optimum braking power and necessary turning force to the street. It hence becomes nearly impossible to evade an obstacle. ABS, the anti-lock braking system from Bosch, prevents locking of the wheels. ABS ensures that the vehicle remains steerable and stable while fully applying the brakes. The ABS control unit also continuously monitors all wheels by means of wheel speed sensors. Should the system recognize that a wheel is locked, ABS immediately intervenes and systematically regulates braking pressure. ABS can regulate each individual wheel within milliseconds. With the electronic anti-lock braking system, a sort of electronic intermittent braking, ABS achieves stability and steerability with the shortest possible braking distance. Let's have a look at the ABS benefits in practice. Full braking at 100 kilometers per hour. With ABS, the braking distance is significantly shorter and the vehicle remains stable. Full braking in a curve. Without ABS, should the wheels lock while applying full brakes along a curve, the vehicle can no longer be steered and slips out of the curve. With ABS, you have the vehicle under control and you can steer systematically. Full braking and swerving. Should the braking distance not suffice, the driver must swerve to evade the obstacle. Without ABS, the vehicle cannot respond to the driver's steering attempts. With ABS, your vehicle remains steerable and stable. A collision is thus avoidable. Full braking on different surfaces. Traction on lanes may vary due to volatile weather, dirt, and foliage. When fully applying brakes without ABS, the vehicle can quickly become unstable. With ABS, the vehicle remains stable, even in this situation, with an optimal braking distance.
In everyday life, these abilities of ABS.
So as you can see over here, we just saw that how ABS can be fruitful and how it can prevent collision, and you can have control of your vehicle with that. Similarly, we will have a look at the video of electronic stability control and how it can prevent accidents.
As you drive, many forces act upon your vehicle. You probably feel some of them in everyday driving, like when you lean toward the side in a corner. When you turn the steering wheel, your car doesn't just move to one side. It actually rotates about a vertical axis. Under some conditions, the car might rotate too much or not enough. Like when you swerve to avoid an obstacle, take a curve too fast, or encounter a slippery road. This is why Mercedes-Benz invented ESP, the Electronic Stability Program. ESP's network of sensors, one of the most advanced in the industry, continually monitors how well the car is carrying out the driver's orders. ESP compares your steering inputs to the speed of each wheel and the car's rotation. Within milliseconds, ESP can sense if the car is not following your intended course. When you quickly steer to avoid an obstacle, the car wants to continue straight ahead. ESP brakes the inside rear wheel. This creates a rotational force that helps the car steer where you tell it to. As you recover, the rear of the car can spin out. ESP brakes the outside front wheel to help rotate the car back on course. If necessary, ESP can also reduce the engine's power to help restore control more quickly. When the laws of physics meet human nature, ESP helps keep you on course and in control.
Dynamic Stability Control, DSC, prevents the drive wheels from spinning and detects unstable driving conditions affecting your vehicle. During cornering without DSC and without adjusting your speed, the vehicle will tend to slide. DSC detects this state and helps prevent the vehicle from sliding. To do this, the system reduces engine output. Brake activation in the individual wheels provides additional vehicle stability.
As a result, the Dynamic Stability Control, DSC, helps you keep your vehicle safely on course within the applicable physical limits.
Good grammar and spelling?
So we have seen over here. Now I'll just come back to the presentation, what we are discussing. Just a minute. So the presentation is visible?
Yes, sir, it's visible.
Okay. So we have seen about anti-lock braking system and traction control system and stability control system. Now these are the typical safety features what we had. Now with that safety being one of the prime focuses of automotive industry with leading road accidents and deaths, there are many technologies which are emerging, like cruise control, which is again an older one. Then we have steering control, suspension control, road sign detection. I'll explain a bit of about everything. Cruise control is wherein you can set a particular speed limit and you can drive in that particular speed constantly without being engaged with the vehicle. Now, with the things coming up in future, we also have adaptive cruise control, wherein the cruise speed can be adjusted with the speed of the vehicle in front of us, so that we can the collision is prevented. And also we do not need to worry about again and again re-engaging the cruise control. Then steering control is wherein if suppose driver is not very what we can say conscious about the road, what he can do is he can if he misses out something, then your vehicle on its own can steer from the dangerous things like a car ahead or the pedestrian ahead. It will do the maneuvering by its own. The vehicle will see that there is an obstacle in front of it which can lead to accident, and it can control it. Then there is road sign detection. Road sign detection is like we have various speed limits or road signs like speed breakers and everything. So uh, uh, there are cameras and there are things inside the vehicle. They can see the road signs and detect whether the speed limit is 40. If in case you are driving above 40, there will be a warning inside your cluster. Yes, that you are driving over speed. Or suppose there is a breaker ahead and you misses out, then the vehicle will automatically brake your vehicle so that you are not subjected to a sudden rash driving kind of a scene. Then intelligent speed assistance. Intelligent speed assistance is what I said, that the vehicle will drive with the speed as per the speed of vehicle ahead of it. Then autonomous emergency braking. Autonomous emergency braking is suppose driver misses out anything, the vehicle will brake automatically, and so that the collision is prevented. Then cross traffic assist is also similar thing. Then blind spot detection. Now there are few areas where we cannot see the occupants of the vehicle from those particular spots, like a pillar comes in between, or when we see rear view mirror, there is a portion of it where we cannot see if the vehicle is very near to us. In that case, you will get a beep that yes, in the blind spots there is someone and you need to be careful about it. Then there is lane departure warning, like when you are driving on a highway and you need to overtake and you need to control, so accordingly the lane is controlled, and you get proper warning lights that you have completely crossed the vehicle, so that you are again on track. Then light source recognition. If suppose somebody comes in from anywhere or you are not able to see it, the headlights of other vehicle or anything, so that this also prevents it. Now pedestrian detection is another thing similar to that. It will detect the obstacle and we can avoid the collision. Vision enhancement at night, when you are driving, the visibility is very less, or in case of fog, the visibility is very less. So there are thermal visions as well. So if suppose there is no physical visibility, then thermal camera can let you know that if someone is there or is there any obstacle or not. So that will create an augmented vision and you will be able to see the things clearly which are not visible from the physical eye. Then there are adaptive headlights. Adaptive headlights does a function of like when you're driving and some vehicle comes from in front of us, their headlight is very high, as you can see, but in this case the lights will automatically be adjusted in a way that the vehicle in front of us is not getting obstructed by the lights of us. Similarly, when you are turning, the light goes straight, and on the turn you have a blind spot, or you cannot you do not have visibility of the headlight. So with the turn, when you take a turn, the lights also turn in the direction of the road so that you have complete visibility and light throughout. We will see again two videos of lane assist control and also adaptive headlights for you so that you can understand it in a better way. I'll just share that.
The new Toyota Safety Sense 2.0 package adds technologies and capabilities that enhance protection for drivers, passengers, and others who share the road. One example of these new capabilities is the addition of the Lane Tracing Assist feature. The Lane Tracing Assist feature can only be activated when full-speed dynamic radar cruise control is in operation and is not available on models equipped with a manual transmission. The benefit of this feature is to help reduce driver fatigue and support safe driving, especially in traffic congestion or long highway trips. Lane Tracing Assist operates by making use of both the camera that is centered at the top of the windshield and the millimeter wave radar located at the front of the vehicle. These two pieces of equipment recognize white and yellow lane markings or the path of a preceding vehicle if lane markers are temporarily not available. By doing so, the vehicle can identify and actively track the center of the lane when dynamic radar cruise control is activated by providing steering assistance to the driver even on curved roads. When in use, the Lane Tracing Assist feature can be identified by two new blue lines that are located outside of the pre-existing white lane markers shown on the multi-information display. If lane markers are not clearly visible, the system will also operate by tracking the path of the preceding vehicle ahead. This operation can be identified by three white dots appearing in the MID display instead of blue lines. It is important to note that both the Lane Tracing Assist and Lane Departure Alert adjustments are incorporated together within the same MID menu labeled as LTA, but can be used separately. Within the LTA menu located in the MID display, both the lane centering and steering assist functions must be set to ON for the Lane Tracing Assist feature to be activated. In order for the Lane Departure Alert with Steering Assist feature to be activated, only the Steering Assist function must be set to ON. When the Lane Departure Alert system activates Steering Assist, you will notice that the blue LTA lines will appear on either side of the vehicle where Steering Assist is being applied. If both lane centering and steering assist are turned off, the Lane Departure Alert feature will still provide audible and visual alerts if the system is enabled by the steering wheel controls. On and off capability of these features is controlled by the LDA button located on the steering wheel. This button will enable and disable both the Lane Tracing Assist and Lane Departure Alert feature. The Lane Departure Assist symbol located within the MID also indicates which feature is activated. When the symbol is illuminated in green, the Lane Tracing Assist feature is active. When illuminated in white, the Lane Departure System is active. If no symbol is visible, both systems have been disabled. The Lane Tracing Assist feature is not a replacement for safe driving practices, and as such, if the driver removes both hands from the steering wheel, the Lane Tracing Assist system will automatically deactivate. Thanks for watching this Know Your Toyota video.
Now we will have a look at the adaptive headlights.
Adaptive headlight systems are made up of several subcomponents that are monitored and controlled by an electronic control unit (ECU). The subcomponents include 1. Wheel speed sensors that monitor the speed of rotation of each wheel. 2. A yaw sensor that tracks a vehicle's side-to-side movement, e.g., when turning a corner. 3. A steering input sensor that monitors the angle of the steering wheel and small motors attached to each headlight. The data from the sensors are interpreted by the ECU, which then determines the vehicle's speed and the angle and length of the curve it is negotiating. The ECU directs the motors attached to each headlight to move the beam to the degree specified by the ECU. Most adaptive headlight systems can turn the headlights up to 15 degrees per side. Newer versions of the advanced headlight system have even larger ranges of motion. Most adaptive headlight setups also include a self-leveling system. This system helps prevent headlights from pointing too far up or too far down when driving up or down hills. A self-leveling system includes a level sensor that sends information to the ECU about the vehicle's position, specifically whether it is tilted forward or backwards. The headlights are then moved up or down to correct for the vehicle's positioning.
Sir, please unmute your mic, sir.
Yes. Okay. So now is it audible?
Yes, sir. It's audible.
Okay. So examples of passive safety system is seat belts, airbags, body structure with programmed deformation, retractable steering column, head restraint, seats with anti-submarine effect, and fuel cutoff. Now, what are these? Seat belts, everybody have heard of. Airbags, I am sure everybody have heard of. Now, body structure with programmed deformation. It is something like whenever the body design is taken place. So, in case the collision occurs, the body deformation takes place in such a way that there are no sharp edges are formed, and there is a crash zone, or you can say impact absorbing zone, which absorbs the impact and reduces the intensity of the impact. Third thing is, it is also made sure that any of the body parts or metal parts do not come inside the occupant area to harm, or they do not fly off so that it can hurt any pedestrian. Then retractable steering column is something, whenever accident happens, the steering column collapses and there is a distance created between the occupant and the steering, so that the steering column does not go inside the driver's abdomen and do the injury. Head restraints, you might have seen everywhere, like head restraints is above the seat. What you see is the head restraint. In case the head restraint is not there, there can be an injury called as neck snap. Neck snap is something like As soon as the accident happens, because of the jerk created, your body, your head tends to move back. If suppose the head restraint is not there, you will go back and your neck will be snapped, and that is very dangerous. Now, seats with anti-submarine effect. Anti-submarine effect is there is a bucket kind of a thing created inside the seat. So when the accident happens, you do not tend to slip ahead. You tend to be in the seat, seated in a comfortable position, and you don't slip ahead, so that you crash into the dashboard or windshield or something like that. Then fuel cutoff. As soon as the accident happens, the fuel, there is a signal and the fuel pump is off and the fuel is not supplied to the engine, which can prevent fire. So these are all the typical passive safety systems what we have heard of. Now in new internet cars or e-cars, what we are hearing is there's emerging called automatic emergency call, in which what we can do is as soon as the accident happens, there are predefined emergency contacts. You can modify it as per your thing, that these people should be aware if I have been met with an accident. So the call goes to those people that this car has been crashed and the occupant inside it, whatever is the condition, the emergency call will go, so that your near and dear ones can immediately respond to it and you can get the assistance. Also, the messages go to emergency call center in case of a crash, so that the SOS services or emergency services are available as soon as possible. They also send the location of the vehicle, so that people can track you and reach you as soon as possible. So this is regarding all the passive safety systems what we have heard. Now, as we have seen throughout the presentation, active is collision mitigation and control of vehicles so that the accident does not happen. Passive system is once the accident has happened, what all we can do to avoid or reduce the damage and save the human lives either inside the car or outside the car. What all we can do for it. So this is the complete summary of the things what we have started. Active safety system, if you go automatic emergency braking, collision avoidance, parking collision avoidance, hazard braking, braking preparation, lateral control, acceleration, stop and roll, acceleration, stop and go, longitudinal control. Then there is all-round vision, navigation, video, radar, ultrasonic. Then if you say about passive safety, traffic member recognition, collision warning, pre-crash, and over here also lane departure warning, blind spot detection, night vision. So these are all in combination makes your vehicle safe to drive in road and can save multiple human lives. We are ready for questions. So Sahil, any questions, and so we can address them.
Sir,
Sahil?
yes, sir.
Yes.
I'm just
questions.
waiting for the questions from the students.
Okay.
I have set my number for the questions to all the students. So we'll just wait for
Okay.
1 to 2 minutes.
Okay. By the time questions is there, I can just brief you about CarMate. So we are an organization. We conduct different engineering workshops and as well as workshops for people who drive cars. You can follow us on Instagram and Facebook. The handle is listed over here, CarMate Tech Center. So you can follow us on Instagram and Facebook, and we share regular inputs on automotive technologies, different automotive technologies. We share regular posts so that the learning is better and people can learn in a better way and in a more just a platform to learn.
Okay, sir. Hello.
Hello.
Yes, sir. It is a one question from the student that how it is regarding his career advice. Actually, he is asking that what I will do after my completing the diploma studies if I want to go ahead in the career of design. design segment.
Okay. So if in case he is looking specifically for design, I would suggest him to complete his degree as well, because with diploma, design opportunities in industries are very less. So first thing is he should complete his degree, and then he can have multiple options for a job. But with diploma standalone design, getting a good design engineer job is a little difficult. Sahil, can
Yes,
you
sir.
hear me?
Yes, sir.
Yes.
Yes.
Yeah.
Okay,
So
thank you.
was the answer clear?
Yes, sir. This answer is audible. Uh,
Okay.
okay, sir. So can we end the session here, sir? Because
Sure, we can.
and sir, you can share this Carmet Tech Center information to the students, and also you can share me the link to follow this on the Instagram and Facebook pages. So can I
Okay.
that I can share it with the students, so students can follow on this particular platform.
Correct.
And once again, thank you so much, sir, for this useful
No, it's
and
I am honored to be part of it.
valuable time.
Thank you. I am honored to be a part of this drive, and anywhere in future also I'll be always happy to be a part of any such thing.
Okay, sir. Welcome, sir.
Okay.
Once
Thank
again,
you.
thank you, sir.
Yes.
Thank you so much.
Thank you. Have a good day. Bye bye.
Okay, bye bye, sir.